least I had my videos because my students couldn't see me for a few minutes. Okay, so in 25, we have x squared minus 5x minus 5x cubed plus x to the fourth divided by 5 plus x. Of course, this is intentional. It's all in a disorganized manner, top and bottom, of course. I will have to spend time to present both polynomials in descending order. The degree is 4. The next one is negative 5x to the third. The next one must be positive x squared, and the last one must be minus 5x. The denominator has to be x plus 5. It happens that we can divide using long division as well as synthetic division. We'll come back to it. For the long division, we realize that there is no missing term, so I don't have to leave any space. So I write x to the fourth minus 5x cubed plus x squared minus 5x. What is missing here is the last term, but who cares? It's at the end. I don't need to leave any space for it. X plus 5. And now my next question to myself is x times what is x to the fourth? And I will write x to the third. I go back to distribute to both terms. I immediately change the sign. You can use the method from the book that says change the sign later. No, I think that method is confusing, but if it works for you, I'm fine. X to the third times x is x to the fourth, but I have to change the sign. X to the third times 5 is positive 5x cubed, but I have to change the sign. Perform the operations I see, not reverse, not opposite. I see that, and it's negative 10x cubed. I bring down the next in line. X times what is negative 10x cubed? The answer is negative 10x squared. Notice that if I start with x cubed, the next has to be lower in degree. Absolutely always lower, by 1 or more, but definitely lower than degree of the previous term. I distribute negative 10x squared to both terms, change the sign, and write underneath. Negative 10x squared times x is negative 10x cubed. Change the sign. Negative 10x squared times 5 is negative 50x squared. Change the sign. Perform the operations I see, which gives me 51x squared. I bring down the next in line. X times what is positive 51x squared is positive 51x. 51x times x is 51x squared. Change the sign. 51x times 5 is 255. 5 times 1, 5 times 5. 255, but it's positive, x. Positive, negative now. Perform the operations I see. Negative 260x. Nothing else to bring down. X times what is this? The answer is negative 260. Negative 260 times x is negative 260x, but I have to change the sign. And negative 260 times 5 will be negative, but I have to change the sign. And I get 0, 5 times 6, 30, 0, and we carry 3, and 1, 3. And this is it. So how do I write the answer? It has to be quotient plus remainder over the divisor. So the division of x to the fourth minus 5x cubed plus x squared minus 5x over x plus 5 is quotient. This is the quotient. This is the result. X cubed minus 10x squared plus 51x minus 260. Plus, because it's positive. If this number, the remainder, were negative, I would have written negative, but it's positive. So positive, remainder, 1300 divided by the divisor, x plus 5. Okay, now, one other thing that I would like to refresh your memory on, and I need more paper, sorry, 1 second. I need more paper. because I only have 2 pages left, I think. Sorry about that. I should have been prepared. So the remaining division of this division must be p of -5.
The division was a polynomial divided by x plus 5, which means x minus -5. This is the a that gets plugged in. If this answer is not 1300, then I have an error somewhere. So let's put the polynomial in the graphing calculator in y equals, clear if you have anything else. I'm going to enter the numerator, x to the 4th, minus. Stop me if you have any questions, please. I don't want to teach myself. So plus x squared and minus 5x. So I enter the polynomial from the numerator, and I want to enter a second table. I want to enter this number. If when I click after I enter -5, I click enter and I don't get 1300, my calculations are wrong. I have to go back to the drawing board. I plugged in -5 and the answer is positive 1300. So that's okay. So I can determine the remainder of a division only if the denominator is like this, meaning x minus a number. In this case, the number a is -5. So now this was the long division. So let's determine the answer, quotient, and remainder using the synthetic division now. The synthetic division is easier, much shorter. However, it's not applicable if the denominator is not of this form. It's not. So, the synthetic division. In the box, I have to enter a, which is this number. When we compare x minus a to x plus 5, we get a equals -5. So that's the number that goes in the box. Now carefully, I have to put all the coefficients, including the missing ones, as zeros. 1, the next coefficient is -5, leave some room. The next coefficient is 1, the next coefficient is -5, and the last coefficient is 0. We do not do anything with the first. The leading coefficient always gets copied, no matter what it is. We do not apply any procedure, anything to it. And then we continue. Remember, when I get done here, this number has to be 1300. If it's not 1300, I have an error. I have to go back to the drawing board. So -5 times 1 is -5. I write it above the line and I perform the operations I see. Nothing hidden here. -5 minus 5 is -10. -5 times -10 is positive 50. I have to write it above the line. I perform the operations. 50 plus 1, 51. -5 times 51, I get -255. 5 times 5 is 1. 5 times 5 is 25. I perform the operations I see, and I get -260. And I already performed this calculation a minute ago. -5 times -260, I get 0. I get 0 and 3 and 1, 3. And it's 0 plus 1300 is 1300. How do I read the answer? I divided degree 5 by degree 1. This must be the coefficient of degree 4. The next one must be the coefficient of degree 3. The next one must be the coefficient of degree 2. No, it was 4 and 3. 4 and 1, right? Sorry. It was not degree 5, it was degree 4. Okay, so 3 and 2 and 1, I don't have to write it, minus 260 plus 1300 over x plus 5. I took my paper away. So it was degree 4. When I divide degree 4 by degree 1, I always get degree 3, and it makes sense. Degree 3, degree 2, degree 1, no degree, degree 0, plus remainder over the divisor. Any questions? Any questions?
Is this good enough? Can we go back now to the last section, 3.6?
No questions.
Okay. Do we need more synthetic division and long division? Anyone? Okay, so back then to page at the end of 3.6. I'm trying to find, maybe it's page 450. 450. Enter. Okay. I'm getting close. So let's choose. Okay, I got it. Page 452. Is it 452? No. I went too far. I went to modeling and we don't need that section here. 440. If you find it before I do, don't torture me. Tell me what it is. $440. Okay, I'm getting very close. Okay. Yes, page 441. Okay. I will pick a few, you will pick a few. I would like to pick 22. 22 on page 441. And we get 3x squared minus 5x less than or equal to 0. This is a polynomial inequality, specifically quadratic. Quadratic inequality. We need to have factor. That's the easiest. When the free term is missing, the third term, the term without x is missing, is the easiest. We factor out x and we get 3x minus 5 less than or equal to 0. I recommend the table and the method I showed you last time because the method in the book, I think it could be confusing. Yes, you can still plug in numbers, but it may have you may have difficulties in identifying when to use a bracket and when not. So that's why I highly recommend my method, but I accept any. Okay, so here's what we did last time. I'm going to go to the next page. I don't want to squeeze it in there. So x is the variable in the problem. Then x is the first factor. The second factor is 3x minus 5. And of course, the last row must be what I'm interested in. What am I interested in? X times 3x minus 5. Notice, like I said last time, the table cannot be applied if one side is not a product or a ratio and the right-hand side is 0, or vice versa. It can be the other way around. It doesn't matter. But one side must be 0 and the other side must be a product or a ratio. We're going to look at the ratio in a minute. Of course, x in the problem can be anything. Now, this x could be 0 when x is 0. This is 0. Let's write it. 3x minus 5 equals 0. I move 5 to the other side. I don't need this anymore. Yes, I do need it for the sign. And then I get 3x equals 5 or x equals 5/3. So these are my numbers in the table. 5/3 and 0 in ascending order. Very important. 0, 5/3. This row has its 0 under 0. This row has its 0 under 5/3. And this row has its 0 under both. Why? Because the product is 0 if either factor is 0. And now, yes, you can plug in numbers to the left of 0, to the right of 0, to the left of 0. I don't recommend that. It's up to you. These are linear functions, and we know how to graph them. Both have a positive leading coefficient. They go from negative to positive, and that's it. They are negative before they are 0, and after that, they're positive. I multiply two negatives. I multiply a positive and a negative, and I multiply two positives. So now, they want us to find whatever x that makes this expression less than 0, but only negative is less than 0. Is this product ever negative? Yes, it is. So for x between 0 and 5/3, x in the interval 0, 5/3. And that's how we solve a quadratic inequality. Any questions?